So today I've got 1 gallon and 3.785 liters, and this is what we're going to talk about today. So what we're going to do today is talk about conversions and how we can convert from one unit to another. And this concept is going to be crucial for everything we do for the entire year. So make sure you get it down now so that you can save yourself some struggles later. Now what we're going to do is we're going to start off by asking a couple questions. What is 24 inches the same as? And by answering this question, I think it'll illustrate what we're trying to do. Well, what we know is that 12 inches is the same as 1 foot. And so if 12 inches is 1 foot, what is 24 inches equal to? Well, 24 inches is equal to 2 feet. Now, something that I want to point out here is how can 24 and 2 be equal to each other? Well, it can be equal because we're using different scales. Now, another thing that we know is we know 1 inch is equal to 2.54 centimeters. So that means that 24 inches is equal to 60.96 centimeters. We also know that 1 inch is equal to 0.0254 meters, which means that 24 inches is 0.6096 meters. Now notice how, again, the 24 inches is the same as 0.6096 meters. So notice how those numbers are different, but they are the same. So let's go ahead and talk about how many liters are in 2 gallons. Well, we know that 1 gallon is equal to 3.785 liters. And so we can do a conversion to then figure out how many liters are in that many gallons. And so this equation that popped up here is how we're going to convert things moving forward. Now the first thing we need to talk about is what a statement of equality is. A statement of equality is just a statement stating how 2 units are equal to each other. And so an example of that is 1 gallon is equal to 3.785 liters. And so that is a statement of equality. And you can do this with a variety of units. The next thing that we're going to talk about is a conversion factor. And so a conversion factor is a ratio that is derived from the statement of equality that we will use to convert between units. Now here is an example of a conversion factor. Notice how there's 2. We take the statement of equality, 1 gallon is equal to 3.785 liters, and then we can make a conversion factor which shows the ratio. So we know that 3.785 liters is equivalent to 1 gallon, and that 1 gallon is equivalent to 3.785 liters. Something to keep in mind, and this is going to be very important, is that conversion factors are always going to be equal to 1. And so because they're equal to 1, whenever you're going to convert, and I'll show an example of this in a moment, you're not changing the quantity, you're just changing the units. The number might change. For example, when we convert from inches to feet, 24 inches is 2 feet. The number is changing, however, the quantity is not changing. So let's go ahead and take a look at just some basic math that will help us understand how conversion factors are equal to 1. Notice how 10 is equal to 2 times 5. I think there's a little debate about that. And so if we take 2 times 5 and divide it by 10, what does that equal to? That is equal to 1. And the reason why it's equal to 1 is because 10 is equal to 2.5. So when you divide them, it equals to 1. Let's go ahead and think about if x is equal to x. I mean, that's pretty obvious as well. If you take x and you divide it by x, what does that equal? That equals 1. Well, what about 1 gallon is equal to 3.785 liters? Well, what if you took your 3.785 liters and you divided it by 1 gallon? What you would end up getting is something that is equal to 1 because they're equal to each other. Now, I know that mathematically you're going to look at that and you're saying, oh, that can't be so because we know 3.785 divided by 1 is equal to 3.785. But the point is that because those are equal to each other, when you divide them, it is equal to 1. Now, what about the other way around? What if we took 1 gallon and divided it by 3.875 liters? Well, again, you're going to end up with a quantity of 1. It's going to equal 1. And so that's something important to note when we're doing this. So when completing conversion calculation, it's going to be really important to choose the conversion factor that cancels out the undesirable units. And I'm going to go through an example of this in a moment. And the units that are left over after all the units are canceled are going to be your final units. So here is something that I want to show you about how units cancels. And so let's go ahead and think of 2x times x. Well, 2x times x happens to be 2x squared. So in this situation, the x's do not cancel out. However, 2x divided by x, they actually do cancel out. So we can cancel out those x's, and what we're ending up with is 2. And so what we want to do is we want to do the same thing with units. We want to cancel the units out. And the way they cancel out is if you have a unit on top and a unit on bottom, they cancel out. But if you end up with 2 units on top who are the same units on top, they will not cancel out. So here's an example of that. So we want to do the same thing with units. Now, in this setup here, you can see how we're converting from 2 gallons into liters. We're taking the 2 gallons and converting it to liters. Notice how if you're starting with gallons, the only way to cancel it out is to put gallons on the bottom of the next of the conversion factor. Because when you put gallons on the bottom of the conversion factor, the gallons cancel out. And we're left with liters. Notice how the units that are left over are liters. And so this, by canceling the units, will help us use the correct conversion factor. Now, let me show you an example of what is incorrect. What if we used a different conversion, or the other conversion factor between gallon and liters? Notice how if we end up putting liters on the bottom, the gallons do not cancel out. We end up with gallons squared over liters. And so this right here, because the units don't cancel out, is the incorrect way of converting. And so as a rule of thumb, whatever units you're starting with, for example, in this situation we're starting with gallons, we will end up putting gallons on the bottom. If we were to start with liters, however, we would end up taking the liters and putting the liters on the bottom. And so following that rule, whatever you're starting with goes on the bottom, will always help you go in the right direction. And that is not the right direction. The last thing that I'm going to leave you with is the metric system. Now, for this class, we're going to solely deal with meters, liters, and grams, but the metric system does apply to other things, for example, like megabytes or gigabytes. But essentially what the metric system does is it is a type of conversion using powers of 10. And so we can take what would be very, very large numbers. For example, a gigabyte, that's a billion bytes, or a terabyte, which is a trillion bytes. We can take those and these large quantities and make them again into smaller, more manageable quantities. And so if you take a look here, if you go down the list, you'll see that we have the different prefixes in the metric system. And I will go through some examples of this, but something that you need to know is that this chart here, you need to have this chart memorized. And it looks like something that's big to memorize. However, if you look at the conversion factor, the 3 conversion factor columns, or the 4 conversion factor columns, you'll see that they're all the same. It's just all the same. Really, 1 giga is 10 to the 9. 1 mega is 10 to the 6. And 1 kilo is 10 to the 3, and so on. And then we go all the way down to nano, which is 10 to the negative 9. So there's a pattern that I want you to notice here. Notice in the middle is where we have the base. And from there, going up, it goes 10 to the 1, 10 to the 2, 10 to the 3, and then it goes 10 to the 6, 10 to the 9. So it counts to 3 and then goes by 3. And then on the bottom part, it's the same exact thing except for it's negative. So it's -1, 10 to the -2, 10 to the -3, and then it counts by 3. So it'd be 10 to the -6, 10 to the -9. And so you do need to have this down. Yet you need to know that nano means 1 nano is 10 to the -9. So an example would be 1 nanometer is 10 to the -9 meters. 1 nanogram is 10 to the -9 grams. And you can put any unit you want in there. 1 nanometer is 10 to the -9 meters. And so whatever you put in there, you just need to know that 1 nano is 10 to the -9, or 1 micro is 10 to the -6. So make sure you get this down. We're going to do a lot of practice problems with this. This is something that you will see for the remainder of the year. And that's it for conversions. So we're going to do some guided practice problems. I'm going to show you how to go through. Definitely watch my guided practice problem video on this so that you can really understand. And again, this is something that's going to be really, really important for you to get down. All right? You're going to do great on it though, I know. And so feel free to ask me any questions you want on it.